Hi all, in this video we are going to see how does industrial wireless communication works. Wireless technologies become progressively widespread in industrial automation applications. Over the last 10 years, radio technologies have become standardized like wireless LAN and Bluetooth technology. Powerful advantage with wireless network is that it can be deployed easily to transmit data to areas, eliminating the requirement to run expensive cable infrastructures. In addition to location flexibility, it offers real-time communication for applications such as SCADA and RTU communications. High bandwidth for video transmission is used for radio security and offers a lower total cost of ownership. Have you ever wondered how information like text message, pictures, videos, and voice moves between wireless connected phones, computers, laptops, and cameras? Yeah, it can be realized when we learn about the invisible force performing all the work called electromagnetism. It is the creation of magnetic field from the movement of electrically charged particles or interaction between electricity and magnetism, such as when a changing electric field generates a magnetic field, changing a magnetic field generates an electric field. This force is used to transmit radio waves when alternating electric current flows, propagating the signal through the internal wires into the transmitting antenna, which makes electron to vibrate, producing radio waves. Essentially, the antenna radiates the alternating current as an electromagnetic wave. This is where the wireless transmission starts. When radio waves travel through the air at the speed of light, and when these waves reach the receiving antenna, it makes electron to vibrate within it and reproduces the same waveform generated by the transmitting radio. During this time, the electricity flows into the transmitting antenna and makes the electron to vibrate up and down, creating the radio waves. These radio waves begin to travel at transmitting antenna through the air at the speed of light, and when it waves reach the receiving antenna, it produces the electrons to vibrate inside it, in turn produces the electric current which recreates the original data. The frequency or alternating waveform of the signal changes based on how fast the signal from the transmitter creates the wave with different frequencies. Various frequencies can be used for different purposes. We call a range of different frequencies of a spectrum. It is divided into areas of specific usage or band. Frequency is about how many electromagnetic waves passes through a point of reference every second. This is measured by counting the peaks of each value, which will be measured in units of hertz or cycles per second. Wavelength is the distance measured between the two highest peaks in a wave. This distance is referred to as period. Wavelengths could be smaller than the size of an atom and longer than the diameter of the planet. Within this electromagnetic band of different frequencies, radio waves have the longest wavelength and lowest frequency, which allows them to travel furthest. The different spectrum of band allows FM and AM radio waves, cell phone signals, Wi-Fi signals, and lot more to share because they are grouped within the specific frequency ranges. Some of the specific frequency bands are ELF or extremely low frequency with a frequency of 3 to 30 Hz and a wavelength of 105 to 104 km, and VHF or very high frequency with a frequency of 30 to 300 MHz and a wavelength of 10 to 1 meter, and ultra high frequency or UHF, a frequency of 300 MHz to 3 GHz and a wavelength of 1 meter to 10 centimeter. Various authorities like FCC or ECC, European Electronic Communication Committee, are responsible for assigning the frequency ranges for the specific usage. An electromagnet signal does not go straight out to a receiver after being transmitted, but it radiates the signal in multiple directions. Radio waves can reflect off buildings, they can bend on sharp edges or even scatter on small objects and still able to reach the receiver. During this, the waves radiated from multiple paths which endure different types of attenuation and delay. The receiving antenna captures all the waves as a combined signal, and when the wave travels more than one route, it is called as multipath channel. This multipath channel combined signal now distorted and mixed, which must be decoded by the receiver to read the data generated. This is not easily accomplished since the received signal contains lot of unwanted abnormalities. So that to make the receiver's job easier, we add some additional step before transmission. Before sending any data, transmitting components performs encoding. This encoding operation appends additional bits into the message, which makes the data recovery at the receiver much simpler. After encoding, the digital data are mapped into the symbols and then modulated by varying the signal amplitude, and then it will be passed to the transmitting antenna. This is how industrial communication works. Thank you.